Today we are talking about perfect cubes. So we have our list of perfect squares from the other day. So remember how I created this list. I took 2 and I squared it, and then a perfect square came out. 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. Now there is 1 squared is 1, but it doesn't usually help us, so we don't usually put it in those lists. But 1 is a perfect square, right? Because 1 times 1 is 1. So sometimes we kind of leave that one out, but it is a perfect square. So let's talk about perfect cubes. So I'm going to make the list the same way. I'm just going to start with 1, and I'm going to cube it and see what comes out. What is 1 to the 3rd power? 1. So 1 is not only a perfect square, it's also a perfect cube. Things start to diverge right here, though. 2 cubed is 8. It's not 6. If I wanted you to do 2 times 3, I would just write 2 times 3. 2 to the 3rd power means 2 times 2 times 2, which is 8. So 8 is my next perfect cube. And then 3 cubed, 27. So you'll notice we're getting pretty big pretty quickly. Oh, all right, so 4 cubed, 64. So that's another one that's both, right? It's both a perfect square and a perfect cube. 5 cubed, 125. So again, it's getting really big really fast. So I don't expect you to know all of them. Well, there's no way you could because there's an infinite number. But you should know at least a good handful of them. 6 cubed. Anybody know that one? 216. Let's see if we can get up to 10. Anybody know 7 cubed? 343. 8. I think it's 512.
Yeah, you're right.
Ooh, I love when I'm right. I know. 9 cubed, 729, and then we all know 10 cubed is 1,000. Okay, so yes, they get really big really quick. Usually we kind of just dabble in the first 5. But it's not, I mean, if you were taking the MCAS and they had cube root of 216, all right, well, you're just going to have to try it out. So, remember the other day when we were estimating square roots to the nearest tenth? We're going to try and do the same thing. We're going to try and estimate a cube root to the nearest tenth. So, oh, actually, before we even get there, do you know how to write cube root? All right, so before we start, let's take a look at any given radical. This is going to blow your mind. You ready for this? You ready? So you have this thingy, and then, believe it or not, there is a number right here. I'm just going to write a number sign. There's a number right there. If you're taking a square root, that number is a 2, and we never write it. So, in other words, and that number is called the index. That's its vocab word. Index. So, when I want you to do the square root of 9, there's really a 2 there. But if it's just a 2, we don't have to write it. So now when I want to do a cube root, instead of putting a 2 there or nothing at all, I'm just going to put a 3 there. So it's going to look like that. So that's how I'm going to write in math to you, hey, what's the cube root of 27? So you need to pay attention to that little number right there. If there is no little number right there, it's a square root. And the square root of 27 is totally different than the cube root of 27. The cube root of 27, oh look, it's in my list. What is a cube root of 27? Just 3. The square root of 27 is not 3. Right? It's totally different. If I ask you what the square root of 27 is, you're like, oh, well, 27 is not a perfect square because it's not in my list of perfect squares, right? So the best I could do is split this up into the square root of 9 and the square root of 3. So this answer is actually 3 root 3. So big difference between a cube root and a square root. And that's how you write it, okay? So let's say I were to ask you what the cube root of, hi, oh thanks, Gianna, see, you've been waiting so long. Let's say I ask you to estimate, let's do the cube root of, how about 10? Estimate the cube root of 10 to the nearest tenth. All right, cube root of 10. While I'm thinking about it too, when you write this, I actually didn't write it that great. You kind of want to, I think of this symbol here as like a little perch for a bird, and then this number is like a little bird on the perch. Hey.
Hey, Miss Savia.
Hi.
How are you?
I'm all right.
Let me give you one guess as to what I'm trying to do right now.
Calm down.
No.
Oh,
That wasn't a very good guess.
that was a great guess. Okay,
All females in here.
almost. I have 2 boys.
Guys, you guys are ready to get through this whole course, just the 2 of you?
Since August.
Since August? Jesus. Alright, anyway, you helped me set something up before the last PD day.
Oh.
And I cannot figure out how to send it.
Oh, how the tables have turned. Yes, I will help you.
I found the
Yeah.
menu, remember you took a picture of
Yeah.
it, and last order.
Yeah.
How do I mail it to the whole department?
Do you want me to just do it when I'm...
No.
You want to learn how?
Yes.
Okay. Can I show you in like 10
You don't have
minutes?
to show me.
All
I know
right.
you're busy. I didn't mean to interrupt.
You're on video, by the way.
You guys mind? Who's that?
You're on video.
Oh, you guys.
I'm not kidding. I turned that little cameras in the corner. Don't worry, no one watches it anyway. It's fine. What can you do?
Gentlemen,
Yeah.
um,
All right, so any Hoosers, we got this here. You want to write that 3 so that it's small enough, so like I was saying, it's like a little bird on the perch. What you don't want to do is get lazy, because that means 3 times the square root of 10. You get what I'm saying? You want to make sure that it's clear that you mean the 3rd root of 10 and not 3 times square root 10. Just a note. So be careful. This should be a little number kind of tucked in there. Little bird on a perch there. So in fact, I don't even like how this one is. I should redo it. Should be more like that. Yeah, that's better. Get that 3 really up and in there. So anyway, the cube root of 10. 10's not a perfect cube. But if I'm estimating what it's going to be, can you tell me what the first number is? It's got to be cube root of 10 is between what 2 numbers? 2 and 3. It's got to be, right? Because 10 is in between 8 and 27. So it's got to start 2 point something, right? Now, is it closer to 8 or is it closer to 27? 8, much closer. So I'd probably start with like a 2.1 and see how close to 10 I get. So to do this though, remember we had to do it by hand? Yeah, you have to do it by hand again because we're assuming that we're in the non-calculator section. You have to do it, but you have to cube it. So remember, if you're going to have to square it and then multiply by 2.1 again. So let's multiply 2.1 by 2.1. So there it is squared. Now I have to do 4.41 times another 2.1. And that'll get me my answer cubed, right? There is 2.1 cubed. I get 9.261. Can I get closer? I don't know. I can try 2.2 and cube it and see if that's closer to 10 or further away. So let me just try 2.2. Do the same thing. I'll square it first. .84 times another 2.2. 861 9. Okay, there's my answer for 2.2 cubed. So which one is closer to 10? 2.1 cubed or 2.2 cubed? Yeah, 2.1 cubed is closer. So if this were an MCAS question, 2.1. But they're going to be, right? If this is a multiple choice question, I guarantee you they're going to have 2.1 as choice A, 2.2 as choice B. Maybe one of them you can get rid of. That doesn't make any sense. But they're smart when they're picking the multiple choice choices. You know what I mean? It's not like there's just going to be one of them that makes sense. Usually there's at least two that it could be. And you got to do a little math to figure it out. Does that make sense? So, should I give you one to try without me telling you what to do? What's the first one on your paper there? Cube root of what?
10.
Oh, well, all right. We just did that one. What's the next one?
100.
All right, try cube root of 100. 100 is not a perfect cube. But you can find the first number very quickly, especially if you have this list to look at. It's cube root of 100 has to be between what two numbers?
4 and 10.
Cube root of 100
4 and 5.
has to be between 4 and 5. Does everybody see that? 100 is in between 64 and 125. So the cube root is between 4 and 5. So you're going to ask yourself, well, which one am I closer to? Am I closer to 4 or am I closer to 5? 5. I'm not super close to 5, though, so I wouldn't try like 4.9. Maybe, what would you try maybe?
4.6.
Yeah, try 4.6, maybe a 4.7. See how close you can get to 100. That's your goal. As close to 100 as possible. Doesn't matter if you go over. It's just which one's closest.
It's definitely not 4.7.
Sure.
Wait, is our quiz on this tomorrow? Is that tomorrow?
There'll be one question like this, yeah. Maybe two. The cubes are annoying because they take forever. 'Cause you gotta cube them. So here's my two answers. I tried 4.6 and I did it out and it was a little bit under 100. So I'm like, okay, well, let me try 4.7, see if I can get closer. That gets me a little over 100. So I know it's between the two of these. So now I just gotta figure out, all right, well, which one of these is closer? 4.6, because that's 2 and change away. This is 3.8 too high. So that one's closer, 97, blah, blah, blah. So 4.6. So if I had to estimate the cube root of 100 to the nearest tenth, 4.6 is my best estimation. Does that make sense? All right. So you guys ready to simplify some cube roots? Instead of, so here we were like turning them into decimals. Now I want to simplify them just like you did on this homework that you put up on the board. Like when you had the square root of 50, you didn't turn it into a decimal, you simplified it. We're going to try the same thing. We're going to keep this list of perfect cubes handy because we're going to be using that. Let's start off not too bad. Say I asked you to simplify the cube root of 16. Sixteen is not in this list. 16 is not a perfect cube. The process is the exact same thing that I do for a square root. I'm going to look in my list for the largest perfect cube that divides into 16. So what is the largest perfect cube that divides into 16? 8, right? We're starting off easy. So I split it up just like I did before, but now it's the cube root of 8 times the cube root of 2. Well, I know the cube root of 8. Just 2. So this whole thing is just a 2, and then I just leave cube root of 2. So that is the cube root of 16 simplified. That's it. Same thing as square roots. It's just a different set of numbers because now we're talking perfect cubes instead. Okay? So let's try this one. How about cube root of 150? Which is the largest perfect cube that divides into 150? No one knows.
I'm still doing that.
Yep. Sure. Kaylee, is that some hilarious meme about cube roots? Oh. What is it? 5 as a final answer? So, the largest perfect cube that divides into 150 is... Oh, that's why you were all stuck. Because I messed up. I was supposed to do 250, not 150. Whoopsie doodle. That's why you're all like, there isn't one. Sorry. 250, just kidding around. Now that you see it's 250, now hopefully you realize, oh, that's just 125 and there's two of them. So I would split that up into the cube root of 125 and the cube root of 2. Right? Because 2 times 125 gets me 250. Oh, silly Miss Savia. What is the cube root of 125? 5. So that's just 5 times the cube root of 2. Okay, let's try one where I don't mess up. How about the cube root of 3,000? You got your list in front of you. What's the largest perfect cube that goes into 3,000? 1,000. These are the cubes. 1, 8, 27, 64. This side, the left-hand side. The answer that comes out, the cube root of 1,000, is 10. But this is going to split up into the cube root of 1,000 times the cube root of... Oh! 3, right? Because 3 times 1,000 gets me 3,000. What's the cube root of 1,000? 10. So that's how I get that as my answer. Does this make sense? It's just a different set of numbers. So let me give you 2 to try on your own without me telling you what's what. How about, let's try the cube root of 24, and let's try the cube root of 128. Try these two. Two separate ones, yep. Okay, ready to try? So let's look at the first one, 24. 24 is not a perfect cube, but if I look at my list, the biggest number in that list that divides evenly into 24 is 8. So this one will split up into the cube root of 8 times what? Cube root of 3, right? Because 8 times 3 is 24. I know the cube root of 8, it's just 2. And then that just stays. Cube root of 3 stays as it is. That's it. Did you get it? Yeah. Sure. Did everybody get 2 cube root of 3? Perfect. Now, same thing for the other one. What is the largest number in this list that divides evenly into 128? 64. And how many times does it go in? Twice. What is the cube root of 64? 4, right? So 4, and then the cube root of 2 just stays. There is your answer for that one. All right, are we ready to try with variables? So, let's just recap. The square root of x squared is what? Just x, right? So what do you think the cube root of x cubed is? It's also just x, right? Right? I'm just going to take whatever I have. This is asking me, what do I cube to get x cubed? Well, x, right? Same way, right? If you had other ones, a fourth root of x to the fourth is still just x. The fifth root of x to the fifth is just x. You could keep going all day long. Okay? So what happens if I try and do something like this? What if I want the cube root of x to the 12th? What number would I cube to get x to the 12th that's the same? You're going to notice a pattern real quick here. X to the what? Yes, x to the 4th. Yes. Here's why this works out, okay? If I take x to the 4th and I cube it, isn't that x to the 12th? Right? That gets me x to the 12th. Right? Or you could do x to the 4th cubed like that. Isn't that still x to the 12th? Either way. So that's why it works out. But Taylor noticed a very convenient shortcut. If I just take the exponent and I divide it by the index, I get my answer. That's all we're doing. You actually do it with the square roots too without even realizing it. Look, I'll show you. This was our list from the other day. Isn't there a teeny tiny number right here? What number is right there if none's written? It's really a 2, right? So isn't 8 divided by 2, 4? Isn't 24 divided by 2, 12? Isn't 38 divided by 2, 19? It works the same way for cube roots. So if I wanted to take the cube root of x to the 15th, the answer is just x to the 5th. Look how easy. I just take the exponent and I divide it by the index. And it's whether it's cube roots, square roots, fourth roots, fifth roots, it doesn't matter. They all work that way. Take the exponent, divide it by the index, and that's your answer. So what's the cube root of x to the 300th? X to the 100th. What's the cube root of x to the 60th? Boy, this is easy. Again, we are assuming that all of our variables represent positive numbers because there are some funky things that happen. You'll explore those in Algebra 2. But anyway, the problem comes in when I try and take the cube root of a number that I can't divide by 3. So let's say I tried to take the cube root of, I don't know, how about x to the 20th? Well, 20 doesn't divide by 3 evenly. So just like I had to do with my square roots, right? If I was trying to take the square root of an exponent that was odd, I had to split it up, right? To get an even number and, right? Remember? Yeah? Okay. Remember? Look, right here. See how we did them? See x to the 15th? I had to split it up into x to the 14th and x to the 1st. So it's the same idea. When it was square roots, I always just went down 1. When it's a cube root, it depends. You need to go down to the next number that 3 does go into. If I go down just 1 to x to the 19th, does 3 divide evenly into x to the 19th? You're right. If I went up 1, it would work, but I can't go up. I always have to go down. X to the 18th. So in this case, I don't go down to x to the 19th. I have to go down to x to the 18th. So then what's this one? X to the what? Second, because I have to get back to, if I multiply these two numbers together, it should always get me back to x to the 20th. So, right? X to the 18th times x to the second really is x to the 20th. So I took it and I split it up. But now, look, this is a perfect cube. What is the cube root of x to the 18th? Yes. And this just stays as it is. So sometimes you have to go down 2 from where you were to get the next multiple of 3. Sometimes you have to go down 1. It depends. So let me give you another example. What if I tried to do the cube root of x to the 22nd? 22. Does that divide by 3 evenly? No. But if I go down just 1, I get x to the 21st. And that does divide evenly. So this one would get split like this. X to the 21. And then what's in this one?
X to the 7. Wait, what? Oh, sorry, x to the first.
This one would now have an x to the first.
I was just thinking about the next part.
So now what's this one? X to the 7th. And then that one's just going to stay as it is. So the thing with simplifying variables with cube roots, sometimes you go down once, sometimes you go down twice. You need to keep going down until you hit a multiple of 3. If your original one itself isn't. Does that make sense? So with square rooting, it's a little bit easier because you always just go down 1. Because I just have to get to the next even number, and that's always the one right before it. But with multiples of 3, it's every third is a multiple of 3. So sometimes you're off by 1, sometimes you're off by 2. All right. So we try putting this together? Yes. I love that enthusiasm. Here we go. Let's say I tried the cube root of 16 x to the 12th y to the 29th. All right, so first thing I'm going to do, just like you did with square roots, you're going to break it up into 3 little mini problems. Cube root of 16 times the cube root of x to the 12th times the cube root of y to the 29th. 3 separate mini problems. Okay, let's start off with the cube root of 16. 16's not in this list. So I'm looking for the largest number that is in this list that divides into 16. 8. You're going to have 8 a lot. So that becomes the cube root of 8 times the cube root of 2. What is the cube root of 8? 2. And then the cube root of 2 just stays as it is. Okay, that little mini problem is done. The cube root of x to the 12th, what is that? X to the 4th. We're lucky here. 12 divided by 3 is a nice number. So the answer is just x to the 4th. I don't have to do anything fancy. Unfortunately, on the last one, 29 does not divide by 3 evenly. So then I ask myself, okay, so I have to go down. Can I divide 28 by 3 evenly? No, too bad. Go down one more. Can I divide 27 by 3 evenly? Yes. So I split this up into the cube root of y to the 27th and the cube root of y to the 2nd. Yes. And the cube root of y to the 27th is y to the 9th. And then this just stays as it is. So just like last night, or whatever night we did that homework, anybody not in a root gets multiplied together, they come out in front. Everybody that is in a root, they all get multiplied together, they go at the end. So my final answer looks like this. 2x to the 4th, y to the 9th, and then one big old cube root with 2y squared in it. How bad is that? Is this all right? It's just you have to use your perfect cubes instead, and you just got to make sure you're thinking about cubes instead of squares. So let me give you one more to try without me telling you what to do. Let's try, let's see if I can leave all this up. Let's try the cube root of 5,000 x to the 16th y to the 33rd. Can you all see that? Oh, Kaylee, you got another hilarious meme about cube roots? I didn't know there were so many. Oh my gosh. If you're fairly confident with your answer, raise your hand. If you're pretty sure you got it right. Oh boy. Okay. All right. Well, I think more of you got it right than a lot of you are better at math than you think you are. There's a couple of you that are worse than you think you are, but that's okay. All right. Just call it like it is. All right.
Wait, what's the, could you tell us?
Yes, of course. Yeah, at math.
In this class?
Okay, so first thing, I would break it up. 5,000, x to the 16th, y to the 33rd. The biggest number, biggest perfect cube that goes into 5,000 is 1,000. So hopefully you split it up into 1,000 times 5. So the cube root of 1,000 is just 10. So that one becomes that. Oh, sorry. Can't see. Then I move on to x to the 16th. 16 divided by 3, not a nice number. So then I go down 1, and I ask myself, okay, 15 divided by 3, is that a nice number? Yes, it is. So I can split this up into x to the 15th and x to the 1st, because 15 and 1 get me back to 16. The cube root of x to the 15th is just x to the 5th. That's going to stay as it is, cube root of x to the 1st, whatever. What is the cube root of y to the 33rd? Y to the 11th. 33 divided by 3 is just 11. You didn't have to do anything fancy on that one. So there's all your little pieces, and now all you have to do is multiply them all together. So I would get 10 x to the 5th, y to the 11th, and then 1 cube root with 5x in it. And there is your final answer. Yep.
Whenever like it's all together in like the bracket thing, is that when you do the dividing the x to the 16? I just thought of that. I was like,
So, I'm not sure what you mean. Like when I'm here?
no, never mind.
Are you sure?
Yeah, sure.
Here, well, yes. If it when you're dealing with exponents, so exponents, you take the exponent divided by what's out here. Since 16 can divide by 3 nicely, that's why I had to split that one up. And then 15 does divide by 3 nicely, so then I got my answer. And this one doesn't, so that's why it stays. But 33, I can divide by 3 evenly, so I get to jump right to the answer.
Alright.
Yep. All right, guys. I'm just kidding. You're all great at math. I didn't. Yes, you are.
She's like, actually, you guys are fantastic.
You are.
Oh yeah, 100%.
Well, now we
Because
don't
we all have
believe
A's.
you.
Oh, jeez. Look at those. Look at those multiple choice quizzes. You guys blew me away. So are the SATs. So. Yes. All right. So